Okay, can you hear me? Please send me message. Okay, very good. Okay, give me 1 minute to start because yeah, today you can hear me clearly, no? Good. Okay. Uh, okay. Uh, do you remember what we discussed last day? What we discussed about micrometer screw gauge, no? We discussed about micrometer screw gauge. This is the micrometer screw gauge. Do you remember the parts first? Before we start the lesson, do you remember parts of the micrometer screw gauge? Okay, this is the instrument. Today, uh, I think today in our studio, every disturbance I have fixed. Now you can, from today, you can learn, do everything you can learn without any disturbance. I have everything I have fixed. Okay. Uh, okay. First of all, before we go to the today lesson, do you remember what are the part of this instrument? What are the parts? Can you see? What is this part? What is the name? What is this one? The anvil. Uh, Today only I joined the class. Okay, okay. No, no problem. You can. I will give you. Who is this? Um, Mayam, no? Mayam. I will give you all past recording, and you. I will give you the back. Then you can complete your works. Still, we are doing first lesson. Still, we are doing first lesson. Therefore, no any issue. No any issue. You can cover. Only we. This is our sixth day, no? This is our sixth day. This sixth class. I think within 2 more days we can complete our first lesson. We can complete. Then we can go to the second lesson. Don't worry. You have only 5 days missing. You can cover by recording, and you have full tute pack, full note you have. Then you can cover. Simple. Don't think. You can come to the today lesson. Try to understand. This is our in this lesson. This is the measurement lesson. I will give you a short introduction first because of new students. This is the our first lesson. The lesson is measurement. 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 This is our first lesson. This is measurement. In this lesson, we mainly discussed about measuring instruments. Measuring instrument. Now we are discussing about length measuring instrument. Under length measuring instrument, our first measuring instrument was what? The vernier caliper. We discussed everything we completed. You can go through recording. We discussed every theory parts plus every practicals, or we completed the vernier caliper. Today, last day we start the micrometer screw gauge. Some only part of practical we discuss. Now today is the second day of the micrometer screw gauge. With today class, the micrometer screw gauge is finished. Then next day we start our third measuring instrument, and one by one we complete measuring instrument. That's the first lesson. Very simple. That's the first lesson. Okay. Mayam, are you okay? You can cover all previous things by recording. I will give you full recording packs we have covered up to now. Uh, Now try to adapt to this class. If you not understood, don't think. Okay, you can cover previous part and come to this recording again. You can watch the same recording, this today recording again after class. You can watch. Okay, then is this science mean this is science for technology? No. Then we discuss basic scientific things for technology. If you doing the better thing, you want to watch our first introduction session. Now we are doing the lesson. Watch the as I think I given the link. No, yeah, I given you. Yeah, you have to go through the introduction session. Then I explaining everything. Better to start from beginning. Okay, okay, okay. Come to lesson. Before that, before come to the lesson, I want to tell you. This is your. Give me a second. This is your first tube pack. This is your first tube pack. I think lot of I think a lot of students already taken this tube pack. This is your first tube pack. This is the uh, force, the forces. This is the measurement. Now we are doing lesson. Okay, this is the rotational motion. Our this is the rotational motion tube. Our next lesson tube. Okay, you can if you after join with our class within 3 days or 4 days, within 4 days, probably within 4 days, I will send into your home. Okay, therefore you can complete the first payment, first month payment. Then you can get all recording, all past recording, and the tube pack come to your home. Okay, that's the method. Then you can complete our all past lessons, past lessons we have covered up to now. Okay, okay, come to lesson. Now in lesson we can't discuss these things. That's why I explained everything in the beginning. Okay, come to lesson. Come to lesson. Okay, last day, this is the micrometer screw gauge. No? This is the micrometer screw gauge. Last day I explained what are the parts of this micrometer screw gauge and what are the functions of each part. What are the functions of each part we discussed. Okay, now tell me what is this? You already said this is anvil. This is, what is this part? Spindle, very good. Then what is this? What is this curve shape name? Frame, very good, frame. Then what is the, I don't know, you can see there is a scale, there is a scale. Can you see? You can't, no? Yeah, here light is too high. Because of that, you can't see. Wait, I will show you. Okay, can you see there is a scale here? There is a scale here. Okay, on this sleeve, there is a scale here, no? That we called as what? What is the name? Linear scale. Good, very good. That's a linear scale. Our studio, the light is too high. That's why the small points you can't uh, see. Okay. Then what is this part? No, this part. This we rotating part. Thimble. Very good. Thimble. Thimble. Then what is this scale on this around this thimble? Scale around this thimble. This one. This one. Circular scale. Good. Then what is this part? This final part? Ratchet or thimble head. Good. Ratchet or thimble head, both name we can use. Okay, ratchet or thimble head. Ratchet or thimble head. Okay. Uh, I'll show you parts again. Okay. They are the parts of the micrometer screw gauge. They are the parts. Then you already know now. Now you already know. This is the anvil. This is anvil. Please refresh. Okay, we already discussed in last day. This is anvil and this is spindle. Spindle. This one. The locking lever. Okay, locking lever. This one. The locking lever. This one is locking lever. You can see. What is the function of locking lever? If I lock this, again we can't rotate this thimble or thimble head. Okay, thimble or thimble head. Again uh, we can't rotate. That's a lock. That's a lock. Okay, then this is a sleeve. On this sleeve you can see the linear scale. I told this is linear scale. Linear scale. Then this is the circular scale. You can see around this linear scale, that is circular scale, and thimble head, this circular scale, and this is the frame. You can see all parts are connected to the frame. Yeah. Uh, yeah, that is they are the main parts of the micrometer screw gauge. Main parts of the micrometer screw gauge. Now, main parts of the micrometer screw gauge. Now, do we remember how we get measurement using micrometer screw gauge? I will show again how to get measurement using micrometer screw gauge. How to get measurement using micrometer screw gauge. Okay, now I want to get thickness of the thickness of this cutter. That's a cutter. Oh, I will take a flexible object. Flexible object. Wait. Uh, Today I don't have an eraser or whatever is good. Okay, no issue. We can use this battery. Okay, then I want to get the diameter of this battery. Okay, the diameter of this battery. Okay, how we get the diameter? Okay, now first of all we need to place the object. This is the object. No? First of all we need to place the object near what? Anvil. Near anvil, we need to place the object near anvil. Okay, then what we need to do? What we need to do? We need to rotate by thimble. We need to rotate by thimble. We need to rotate by thimble. When we rotate into right side, okay, this side, clockwise direction, rotate into right side direction. While rotating, what happened? The spindle is, while the circular scale rotating, the spindle is go forward. The spindle is go forward. Okay, the spindle is go forward. You can see this. The spindle is go forward. Okay, the spindle is go forward. Then when it is the spindle go close to the object, when the spindle go close to the object, we need to stop rotating by thimble. We need to stop rotating by thimble. Then we need to start rotating by thimble head. We need to start rotating by thimble head. Then we need to start rotating. Okay, then thimble head, can you see some sound? Can you hear some sound? Can you hear? Yes, there is a sound coming. The sound coming mean the object has tight in required level. You can see we can freely keep between this anvil and spindle. We can freely keep the object is tight in required level. Okay, now using linear scale and circular scale, we can get the measurement. I remember that's last day lesson. Again, I explained. I just refresh you. Okay, up to now, okay. Up to now, okay. Then what is the function of ratchet? I explained last day. The ratchet is the main important part of this micrometer screw gauge. The ratchet is the most important part. What is the function of the ratchet? The ratchet function? Yeah, send me all what is the function of ratchet, then we can go to today lesson. What is the function of ratchet? Send me all, then we can go to today lesson. Okay, good. Lot of answers. The tied the spindle with the object required level, very good. Rotate and tied the anvil with the object as required level, very good. Rotate the spindle and tied the object, the anvil only in required level, very good. Very good, all are correct. This is the correct answer, you all are correct. The answer should be, that is the most important part of object placed in anvil and spindle in with required tightness. Only with required tightness. That is the answer. Only with required tightness. Only with required tightness. Okay. Okay. Now come to the today lesson. Okay. Now come to the today lesson. Now go to the tute first. Go to the tute. Get your tute, measurement tute. Go to the measurement tute. Okay. In this, we are in the page number. Now we are in the page number 8. Go to the page number 8. In measurement tube, page number 8. If you don't have tube, don't think, I will send soon. Within 2 to 3 days, I will send you a tubes. Okay. Okay. In put number 8, the middle paragraph. The middle paragraph of the page number 8, I have mentioned the function of the thimble head or ratchet. The ratchet function I have mentioned in the middle paragraph. Okay, now come to the what is our next topic, subtopic? The linear scale. The linear scale. Okay, now we going to discuss about art and important concept of the micrometer screw gauge and how to read a how to read a measurement of the micrometer screw gauge. That is the most important part of the micrometer screw gauge. Therefore, focus well for today lesson. Actually, now we starting today lesson. I just revise you. I just refresh you. Up to now, I only refresh last day lesson. Okay, come to the lesson. Come to the lesson. Okay, while you asking question, after I start the lesson, only ask lesson related questions. Don't other questions ask at the first, at the beginning of the class or at the end of the class. Don't ask any at other questions while we doing the lesson. Okay, only lesson related, only the micrometer screw gauge related problem only ask while doing lesson. Okay, keep this ethics. Okay, you can ask any question at the beginning, and at the end I will give you time, then you can ask. Okay, no issue. Okay, now you know each part of this instrument. This is micrometer, screw gauge, all parts, the anvil, ratchet, linear scale, circular scale, and thimble head, frame, and lock. Every part you already know. Now we going to discuss about linear scale. Linear scale, in depth about linear scale. The linear scale is a the linear scale is a scale, that's a scale that has calibrated on the sleeve. Sleeve. The sleeve mean like this. A sleeve mean like this. It's a iron cylinder. It's a iron cylinder. On this cylinder, there is a scale has calibrated. That is the linear scale. This linear scale, how these values are marked, that you need to very important to remember. Okay, the values marks in this way. Understand. Think this is that we call the middle axis of the linear scale. That we call the middle. There is a axis that we call the middle axis of the linear scale. Middle axis. I will explain. Simple. The middle axis of the linear scale. The middle axis of the linear scale, there is a line that we call as a middle axis of the linear scale. Now think this is the 0, linear scale 0. This is the 0. And this is the 1, 2, 3, 4, 5. The only 5 by 5 it has mark like your ruler. In your ruler 10 by 10 it has mark 1 centimeter. After 10 parts it is 2 centimeter. But in this linear scale 5 by 5 parts they have mark. Okay, then 6, 7, 8, 9, 10, like this it's continue. That the number of linear scale parts depend on the instrument type. Normally the parts it's going in this instrument, it's 25, up to 25 parts, up to 25 parts, up to 25. That means 2.5 centimeter. Some that's a one type. Some instruments have in the linear scale, they have calibrated up to 5 centimeter. 5 centimeter mean 5 centimeter mean 50 parts. 50 part. But this instrument only in linear scale has calibrated 25 parts. 25 mean 2.5. 2.5. Then this instrument, tell me this instrument what is the maximum value? The maximum value is 2.5 centimeter or 25 millimeter. This instrument, if linear scale parts 50, then the maximum value is 50 millimeter or 5 centimeter. Okay, then this is the linear scale. Very simple. Additionally, it's like this. Each millimeter part has divided into 2, like this. Then how we read this? Very important to read, understand, read, how to read this. Understand, this is the 0. Okay, 0. Then this is 1. 1. The 0 and 1 divide into half, divide into two parts. This one is 0.5. Okay, 0. Then you need to understand how to read the linear scale. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Understood? 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10. Like this. That's how we read the linear scale. Understood? The linear scale is a simple scale on the sleeve that we called as sleeve. That's sleeve. Sleeve. Okay, the sleeve is a iron cylinder. Okay, that's a iron cylinder. That's the iron cylinder. On this iron cylinder, they have calibrated the linear scale. That's the method they have calibrated uh, 0.5 to 0.5 millimeter. Understood? The linear scale understood? Yeah, others? Quickly, send. If not, send me. I will explain again. No any issue. Okay. No any issue. I will explain again. If any point is uh, doubt. If any point has doubt, I will explain again. Very good. Okay, what is the linear scale? The linear scale has calibrated on a sleeve. On a sleeve, you can see that's a sleeve. The sleeve means this part. That's a iron cylinder. Iron cylinder. On this cylinder, that's a linear scale. That's a like a straight line. Okay, in this straight line, on this straight line, the middle line we called as middle axis of the linear scale. Middle axis of the linear scale, they have calibrated in this way. 5 by 5 it has mark. No, 1 2, 1 2 not mark. Okay, 1 2 is not mark here. 1 2 not mark. Only 5 by 5 it has mark. 5 by 5 it has mark. 5 10 I think if you can see, you can understand, but unfortunately you can't see. No, you can't see these values. You can't see. No, then how I show? Now can you can? Can you see some values? See, yeah, values you can't see, but there are some values. No, that is 0, 5, 10, 15, 20, like this. That is a linear scale. That's a linear scale. Uh, yeah, not clear, but that is that's the method. That's a linear scale. Then, if you want, you can get more. That's a linear scale. Uh, then 11, 12, 13, 14, 15. Okay, then 10.5, 11.5, 12.5, 13.5, 14.5. Okay, that's continue up to the value. Okay, up to the maximum value. The maximum value depend on the instrument type. Okay, the maximum value can be 2.5 centimeter. That means 2.5 centimeter mean 25 millimeter. Or 5 5 sorry 5 centimeter. The 5 centimeter mean 50 millimeter. Okay, that depend. according to the instrument type. Okay, go to the tute. I have given a topic linear scale. Under linear scale, I have given the linear scale is set up on a iron sleeve and calibrated to 0.5 millimeter increments. Yeah, 0.5. You can see the gap between two lines, 0.5. The upper line 1 millimeter, but this 1 millimeter divided into two parts. Then the gap is 0.5 millimeter. Okay, can you draw that on this topic? Uh, Near this topic, the linear scale, near the linear scale, you can draw this and name each part. That's the middle axis of the linear scale. That's the iron sleeve, and this is the linear scale. The maximum value depend on the instrument type. Okay, understand very carefully and focus well. Then you can get maximum uh, idea about the micrometer screw gauge. Today, everything we discussed, okay, about micrometer screw gauge, everything we discussed today. Draw this near the linear scale topic and label this name. Completed? Completed. Complete. Others? Are you completed? Yes. Okay. Now go to the second topic. The second topic is the screw gap. The screw gap. Before go to the second topic, go to the third topic. I will explain screw gap later. Third topic, page number 9, the circular scale. The circular scale is like this. The circular scale is like this. It can rotate. When we rotate by thimble, the circular scale is rotating. The circular scale rotating and what happened? The circular scale rotating and can you see it is rotating and go along the linear scale as I explained last day, as a screw nut and screw nail. Okay, the screw nail, you remember? Do you remember? This is the screw nut. Think this is the screw nut. This is the screw nut with threads. Understand? This is the screw nut with threads. Okay, then if I add any nut here, think this is a nut. Think this is a nut. Okay, this nut, when we rotate clockwise or right side direction, what happened? When we rotate right side direction, what happened? It is rotating. When rotating in this way, it's rotating and go forward. Okay, like this. Samely, the circular scale is same like that. The circular scale, can you see? It is rotating and like a screw nut, it's rotating and go forward. Okay, then last day I explained with the both contacting both uh, concept I got as one concept. I told you that we called as screw concept, and screw gauge concept means same. Okay, the screw gauge, the circular scale is same as a screw nut. Same as a screw nut. Then while we rotate this circular scale, you can see while we rotate, it's going forward. It going forward with the uh, okay, while we rotate, can you see? While we rotate, how you can show you? Okay, now think I rotate in clockwise direction. Okay, right side direction. See this spindle? See this spindle? It's rotating and go forward along the linear scale. Okay, it's rotating and go forward. Rotating and go forward. Okay, rotating and go forward. If I rotate in other direction, if I rotate other direction, that means anti-clockwise direction. Anti-clockwise direction, it's rotating and go backward. It's rotating and anti-clockwise direction. If I rotate into anti-clockwise direction, it's rotating and come backward. Okay, that you already, first of all, you should understand this. Then circular scale is same as a screw nut on this nail. I told the in the micrometer screw gauge, the linear scale is equal to screw nail and the circular scale equal to the screw nut. Remember? Then samely, this is the screw nail. The linear scale is the screw nail. Then with threads, they along this linear scale, this screw nut is moving. Screw nut is moving while we rotating. Okay, that's the basic principle of this micrometer screw gauge. Now, the circular scale. The circular scale is like this. The circular scale, think this is the linear scale. This is the linear scale. The sleeve with linear scale. The iron sleeve with linear scale. This is the circular scale. Okay, this is the circular scale. That's like a, okay, this is the circular scale. This one we can rotate. That we called as thimble. That we called as thimble. That is the thimble. Okay, that is the thimble. And thimble head. The thimble head in other side. This part is the circular scale. Then while we rotate by this thimble, the circular scale is already rotating. While we rotate by thimble, the circular scale is rotating. The circular scale rotating, and what happened? The circular scale rotating and it is more along the linear scale. It's, if I rotate right side direction, it's moving into forward. This direction. If I rotate left side or anti-clockwise direction, it's moving into backward direction. Understood? The moving is understood, then otherwise you can't understand this. Are you got the moving mechanism? Are you good? Any doubt about moving mechanism? Yeah, very good. Then while we rotate right side direction, it's more forward. While we rotate left side direction, it's more backward, same as a screw nut. Okay. Send me all. Anyone has any doubt? You can ask. Any doubt? Hmm. Any doubt? Our new student who asked me question. Ah, okay. Okay, very good. Now, Now this circular scale, what happened while we rotate right side direction? It is more forward. While we rotate left side direction, it's more backward. That's the moving mechanism. The circular scale is, it has, that's a cylinder like structure, that's a cylinder. Then this circular scale has divided into 50 parts normally. Okay, the circular scale is divided into 50 equal parts. Understand, this is 50 equal parts. It has calibrated this way. It has calibrated this is the 0. Okay, this is the 0. Then always it has marked in upward. 0, 1, 2, 3, 4, 5, like this. Then 6, 7, 8, 9, 10 again mark. Okay, then 10, 15, 20, around the circular scale. Can you see? Around the circular scale, I think you can't see this value. Yeah, the problem is you can't see this value. Now you can see some values, no? Around the circular scale, you can see some values, no? Then it has mark 0, 1, 2, 3, 4, 5 by 5. It has mark up to which value? Up to 50. Then 5, 10, 15, 20, 25, 30, 35, 50, 35, 40, 40, 35, 40. Then it is 45. It is 44. Then that's a circle. Okay, that's a circle. Then 44, 45, 46, 47, 48, 49. The 50th path is again 0. Understood? That is the circular scale. How to calibrate it? The circular scale calibrated into 50 equal parts. Understood or not? Send me the calibration of the circular scale. Are you got? Very good. It has divided into 50 or 100 or normal one. The normal, the usually use micrometer screw gauge. Normally this one is the our syllabus discussing micrometer screw gauge. This instrument has divided into 50 parts. Okay, 50 parts. You can see this is 0. Then again 0, 5, 10, 15, 20, 25. Then you can see after that it come up to 45. Then after 45, 46, 47, 48, 49. The 50 is not there. The 50th part is again 0. Then the circular scale divided into 50 equal parts. The circular scale divided into 50 equal parts. Okay, that is the circular scale. Can you draw this? Can you draw this? The circular scale divided into 50 equal parts by rotating. Okay, other thing I will explain later. The circular scale normally divided into 50 equal parts. Okay, then better to draw both. Better to both draw both linear scale and circular scale. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's continue. Some part has covered. Then this is the linear scale. This is the linear scale and circular scale both. Okay, now you can understand. Linear scale and circular scale. This is you can label. This is linear scale. This is linear scale. This is circular scale. Circular scale in your drawing you cannot in perfect correct name. Linear scale I use only short form. Then if you want I will write this linear scale. Linear scale. This is the circular scale. circular scale. Linear scale and circular scale. That is the thimble head. Other part you already know. Yeah, sir, will the thimble and ratchet move along the circular scale or not? No, Puta. The thimble and ratchet no moving along the linear scale. Yeah, it's moving. The ratchet is not moving, but thimble is moving. With circular scale moving, the circular scale moving along the linear scale. Therefore, the thimble also moving. Thimble, see, carefully see. See carefully. Now, this is the thimble position. Okay, this is the thimble position. This is the thimble position. Now, when I rotate, the thimble and circular scale both go to this side. See, it's moving. While rotating, it's moving. Moving. The very good. The ratchet is not moving actually. The ratchet is not moving, but with uh, thimble is moving. The thimble is moving, but the thimble moving actually not important. We want to understand the circular scale moving. That's the important for reading. The circular scale moving. The circular scale moving along the linear scale. Along the linear scale. While we rotate, this move into left side, right side and left side. Okay, this is the overall the moving pattern, moving mechanism of the micrometer screw gauge. Okay, now are you completed? Are you completed? Others, I finished. Okay. Now we move into our very important point. Very important point. The topic is the screw gap. The topic is screw gap. The topic is screw gap. What is the meaning of this screw gap? The screw gap or the same we call it is pitch. The screw gap or pitch. The pitch mean cricket pitch, not the cricket pitch, the pitch of the micrometer screw gauge. The screw gap or pitch. What is the meaning? Do you have idea what is the meaning of pitch or what is the meaning of screw gap? What is the meaning of the screw gap or pitch? Do you have idea? Do you know the screw gap or pitch is a exam question in 2000? As I remember, it was an exam question in 2019. I not remember the exact year, but there was 2019 or 17, not 18. 2019 or 17, there was an exam question. What is the meaning of the screw gap? What is the meaning of screw gap? Then, what is the meaning of screw gap in the micrometer screw gauge? Okay, understand the screw gap mean actually if I screw gap or pitch in the on the this screw nut, the between the gap between two trades. They are trades, no? The gap between two trades is the simple meaning of the pitch or screw gap. The pitch or screw gap, the simple meaning is the gap between two trades. That's the simple meaning. When we take any if we take any screw nut, screw nail, on this screw nail, you know it has threads, no? The gap between two threads is the meaning of the screw gap or pitch. But in micrometer screw gauge, the pitch or gap you can't explain like this. In micrometer screw gauge, there is a specific definition for the screw gap or pitch. There is a specific definition that is very important. The screw gap mean, understand, the screw gap mean while rotate full complete revolution of circular scale. Understand, while rotate full complete revolution of the circular scale along linear scale, the circular scale moving distance that we called as the screw gap of the micrometer screw gauge. Anything not you? I think anything you not understood. No? I will tell again. The screw gap mean, try to understand. If not, I will explain. The screw gap mean while rotate full complete revolution of the circular scale along linear scale, circular scale moving distance we called as the screw gap of the micrometer screw gauge. Can you remember? Difficult. Yeah. Then try to get that in practical way. Then you can easily remember. Very small thing, very small point you need to remember. Okay, understand. The screw gap of the micrometer screw gauge mean while rotate full complete revolution of the circular scale. What is the meaning of that? Think this is 0 here. Now the 0 is coincide with the middle axis of the main linear scale. Now at the beginning, at the initial, the 0 and middle axis of the linear scale coincide now. Okay. Now I rotate full complete revolution of the circular scale. That means after full revolution, I take again 0 into middle axis with coincide. Okay, coincide with middle axis. I take again 0 after full revolution. Then that is how many revolution? Full revolution, no? Full one revolution. Within this full one revolution, the along linear scale, the circular scale moving distance is the screw gap. Okay, as example, think initially the circular scale is on this point. After this 0 again, after full revolution, after 0 again come to same position, think the circular scale move into this point. Okay, circular scale moving into this point. Okay, this gap or this distance is the screw gap or pitch. This distance is the screw gap or pitch. Understood? Yeah, you need to understand very practical way. If you read or if you search in internet, any thing you can't understand, you need to understand like this very practical way with diagrams, with figures. You need to understand. After I explain the basic thing, you can read the additional. Okay, you can read some. You can search internet. You can read my note and other any note you can refer. But at the without basic knowledge, if you read anything, you can't understand this type of practical lessons. Okay, but if I explained, you need to participate to class consistency. If you come one day and if you take 2 weeks breaks, then again come, that's not work. Okay, you every day you have to separate your time, class time you have to separate. Our class is not changing like others. Yeah, you know, your ICT, they are class changing. Our class is same time every Thursday. No, any reason the class time is not changing. Okay, if I uh, uh, yeah, any reason if I un if without any uh, necessary reason, I will compulsory reason, I will not change the class date or time. Therefore, you can keep this time free. No, you can easily participate to classes. Then you can understand this concept. Then you can read other things. Okay, first you need to get the basic thing. Okay, then otherwise you can't learn these lessons. Okay, okay, then can you uh, circular scale more front or back above the linear scale? Very good. If I rotate the full one revolution into right side direction, it more back. Sorry, it more forward. If I rotate left side direction, other direction, it's more backward. Any direction, any direction we can rotate. Okay. Now, if I rotate right side direction, it's more into front. If I rotate left side direction, it's more uh, backward. Then this value is same value. If I rotate clockwise or if I rotate other direction, the value is not different. The value is the same value. The value is same value. The thing is, I can see. The thing is, I will try this. Show you this practical. The problem is you can't see these values. No. Then I will try in next day. I will try use some animation to explain them. Okay, then you can get 100% idea. I normally I try to these practicals in actual way. Then, but unfortunately, this value you can't see. If you we did, but vernier caliper there was no problem. But these values you can't see. No. Therefore, I will give you some animation videos. Then you can get 100% idea. Okay, then can you explain the what is the screw gap? Can you explain what is the meaning of screw gap? While rotate full one revolution of while rotate full revolution of circular scale along linear scale, circular scale moving distance we called as the uh, screw gap or pitch. Okay, go to the page number 8, final topic. Page number 8, final topic, screw gap. Screw gap, within bracket you can mention it is pitch. Within bracket, the screw gap equal pitch. In the definition I have given, that's a pitch. When the screw is rotate one revolution, it's more to a distance equal to the gap between two consecutive trades. This is called as a pitch or screw gap. Okay, this definition is little bit complex, no? Therefore, write down the simple definition. Both correct. Okay, both correct. Yeah, same thing I have explained. Write down this definition also. While rotate circular scale, while rotate circular scale, while rotate circular scale, full one revolution, while rotate circular scale, full one revolution, full one revolution, along linear scale, along linear scale, the circular scale moving distance, along linear scale, the circular scale moving distance, the circular scale moving distance called as the screw gap or pitch, called as the screw gap or pitch, called as the screw gap or pitch. Okay, now read the given definition. When the screw is rotated one revolution, the screw mean this. When the screw, I told this is screw, no? When the screw rotate one revolution, moving distance along the threads, along the threads means along the linear scale. Okay, both definition you should know. In the internet's given this definition. That's why I given in the tute. The internet, if you search what is the meaning of screw gap of the micrometer screw gauge, they given this definition. But the simple definition, if you read, if you write in the exam, no issue, you have marks. Okay, the both definitions correct. Okay, for the practical understanding is the thing you should have. Okay, without the theoretical, the by heart knowledge doesn't work. You need, you should know the practical. You should have the practical knowledge on. Okay, now can you go to the next part? Are you got any doubt? Any doubt up to now discussed today? We discussed the linear scale, we discussed the circular scale, we discussed. Then this the screw gap we discussed. Then three topics clear. Only that we discussed today. The other thing last day refreshment. Okay. This tree okay. The linear scale okay. The circular scale okay. The screw gap okay. Now perfect. Send okay or no. Any doubt about this tree you can ask. Sad okay. Janindu. Who others? Sahan. I got up to now. Sad. I don't know. Your name is correct. Sad. Or is it me? Are you correct? Are you clear? Yes. Good. Okay. Now we move into the very important part of the micrometer screw gauge. Micrometer screw gauge, very important part. The topic is the least count of the micrometer screw gauge. Do you remember for vernier caliper also I given equation for least count of the vernier caliper? One segment of the main scale minus one segment of the vernier scale equal to the least count of the vernier caliper. No, that's in the vernier scale, vernier caliper lesson. In today we are going to how we get the least count of the least count of the micrometer screw gauge. Micrometer screw gauge. The least count of the micrometer screw gauge. The least count of the micrometer screw gauge. If you have tute, you can the topic is already given. If you don't have tute, you can you can note down some short note until your tute is coming. Okay, until your tute is coming. Okay, the least count of the micrometer screw gauge. For any micrometer screw gauge, okay, this micrometer screw gauge, if I take some micrometer screw gauge, the least count is already mentioned on the frame. Okay, the least count is already mentioned in the frame, and it has mentioned the maximum value also. The maximum value, the measurement range. Okay, if you don't clear, I will send. I will write 0 point on this frame. They have mentioned 0.01 millimeter on this instrument, 0.01 millimeter, and the measuring range 0 to 25 millimeter they have given. I told this measuring ranges depend on instrument to instrument. The least count also depend on instrument to instrument. This instrument 0.01 millimeter. What is the meaning of least count? Before we go to the least count of the micrometer screw gauge, do you remember what is the meaning of least count? The perfect definition, what? The meaning of the least count, I asked. The least count. Yeah. All send me the least count. That's the first part of the lesson. Least count me. Yeah, others. The minimum value, good. Very good, you made. The minimum measurement that can be taken accurately by any measuring instrument. Very good. Very good. The minimum measurement that can be get any measuring instrument accurately, that we called as the least count. Okay, these instruments given this is 0.1 millimeter, 0.01 millimeter, the least count is given. Now we'll see actually how we calculate if you without knowing without given least count. If anyone given a micrometer screw gauge only without think this value is not visible, then you have to calculate the least count of micrometer screw gauge. The least count of micrometer screw gauge, the least count of micrometer screw gauge, the least count of micrometer screw gauge, the least count of micrometer screw gauge equal to, understand, equal to very simple equation you have, very simple equation. The least count of micrometer screw gauge, the screw gap, the screw gap divide by the number of circular scale parts, the screw gap divide by the number of circular scale parts. Okay, the screw gap divide by the number of circular scale parts, that is the least count of the micrometer screw gauge. Then we'll see this, we'll try this value is correct, this mentioned value is correct. Okay, what is the least, normally the screw gap of this common instrument, it is 0.5 millimeter. The screw gap is, while rotate one full revolution of circular scale, the circular scale moving distance along the linear scale, it is one always, not always, common instrument. That means this type instrument, this type, that's a common instrument, it is 0.5 millimeter. The screw gap. The screw gap is 0.5 millimeter. The number of circular scale parts, what is this instrument? 50. Okay, this instrument number of circular scale parts 50. Then 0.5 minus, sorry, 0.5 divide 50. What's the value? The value is 0.01 millimeter is the least count of this instrument. Correct, no? Yeah. Okay, go to the tute, page number 9. Go to the tute, page number 9. The smallest measurement, that means least count, is obtained by dividing the screw gap by the number of circular scale segment. By the number of circular scale segment, then the least count of the micrometer screw gauge, the equation given, the screw gap or pitch divide by number of circular scale part. The number of circular scale part. Okay, then I have given some space, no? Then I have given some space. On this space, write down first question. We need to write down 3 questions. Therefore, manage the space. Space manage on this given space, given place. Okay, write down first question. There is a micrometer screw gauge. 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 The screw gap 0.5 millimeter and the screw gap 0.5 millimeter and the screw gap 0.5 millimeter and the circular scale has divided into 50 equal parts, and the circular scale divided into 50 equal parts, divided into 50 equal parts. The circular scale divided into 50 equal parts. Calculate the least count of the instrument. Calculate the least count of the instrument. Okay, then write down the equation and get the value. This is the answer, 0.01 millimeter. 0.01 millimeter is this question answer. That's a exam question, exam MCQ. Completed. Completed. Sorry. Are you complete? Okay. Sit. Okay, go to the question number 2. Question number 2. Go to question number 2. Question number 2. There is a micrometer screw gauge. There is a micrometer screw gauge. There is a micrometer screw gauge. There is a micrometer screw gauge with 100 circular scale parts and with 100 circular scale parts and with 100 circular scale parts and while rotate 5 revolution of circular scale, while rotate 5 revolution of the circular scale, while rotate 5 revolution of the circular scale along linear scale, while rotate 5 revolution of circular scale along linear scale, it is moving 10 millimeter distance. It is moving 10 millimeter distance. Calculate the least count of the this instrument. Calculate the least count of this instrument. That was a exam MCQ. That was a exam MCQ. Okay, what do you think? Okay, get the value and send it to chat. Get the value. Very good, Setmal. Others? Yeah, I know today a lot of adverse weather, no? There are a lot of connection issues and thundering, no? Therefore, no issue. I will give you after the class. I will send you the recording. You can refer that. Somehow, don't keep any week work. Don't keep for next week. Okay, they are within the week. Complete all works of this work of each work. Okay, therefore, if there are any problem, if there are any disturb, we are doing the class in same time. Don't think about that. But if you have any doubt, if you have any problem to join, you can watch the recording and somehow you have to complete. Okay, you have options now. I will give you recording and I will give PDF and I will give you the printed note, everything I given. Then you have to use this maxim. Okay, others, what is the answer? What is the answer now? Only 3 answers. Others, listen. Only 4. Yeah, all are correct. Yeah, all are correct. The screw gap is what? The question given. While rotate circular scale 5 revolutions. Understand? While rotate circular scale 5 revolutions. 5 revolutions. What is the distance moving? The distance 10 millimeter distance is more along the linear scale. 10 millimeter distance. 10 millimeter distance. Then what is the screw gap? The screw gap means 1 revolution, 1 full revolution. What is the moving distance? Okay, then within 1 revolution, what is the distance? Only 2 millimeter, 10 over 5. No? It is 2 millimeter. Then the screw gap is 2 millimeter. The screw gap is 2 millimeter. The number of circular scale parts 100. Then 0.02 millimeter is the answer. 0.02 millimeter is the answer. That you need to understand. These type questions are coming in the exam. That was exam question 2021 or 22. MCQ question. Very simple, no? Basic questions asking. Then every concept, if you have idea about every concept, the collect marks is very easy in the exam. But if you don't know this equation, or if you don't know what is the screw gap, think about this question, how you get the answer, no? Okay, think you don't know about this equation, and you don't know what is the meaning of screw gap. Okay, without this knowledge, if you go to find the answer for this question, it is impossible. Therefore, you should know first, you need to understand each concept. Then you can go to questions. Very simple. Okay. Okay, that's the answer. That's the answer. Okay. That enough. Okay. Now we move into most important part of the micrometer screw gauge. Micrometer screw gauge. Taking measurement by using micrometer screw gauge, page number 9. Taking measurements by micrometer screw gauge. Taking measurements. Okay. Uh, Okay, come to this. Okay, this one I want to get the measurement. Okay, this think after I take any measurement, the linear scale and circular scale position was like this. Okay, the linear scale and circular scale position was like this. Okay, before we go to the tute, okay, try to go board, and I will draw and I will explain. Then we can go to the exercise. No, that's better. Okay, now come. This is the linear after I take any measurement. Think I got the thickness or diameter of this pen. The diameter of this pen, the linear scale and circular scale was like this. The linear scale and circular scale was like this. Understand? This is the most important part of the lesson. Okay. Uh, this is the linear scale. This is the linear scale. And this is the circular scale. This is the circular scale. Circular scale, other part I am not going to draw. That's the circular scale and linear scale on. Okay, understand very well. Try to focus maximum. Okay, this is the linear scale 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 30. Then there are 0.5 parts in the below. Okay, that's the linear scale. That's the linear scale. After I take any measurement, that was the linear scale. Okay, then the circular scale position was like this. The circular scale position was like this. It was 15. Then 1, 2, 3, 4. It was 10. it was 20 and other parts, then it is any position. Okay, it is any position. Now you must know, you must understand the how to read this type measurement of the micrometer screw gauge. Think as example, if I take the thickness of this thickness of this pen, the linear scale and circular scale position was like this. You can't see this value, that's why I draw these values. Okay, now understand this part very well, how to read this measure. Okay, how to read this measurement. If I measure, if we can't read this, it's not worth. Then why we take measurement? That is most important part. We going to read this measurement. Okay, my pen thickness I going to read. Okay, read as vernier caliper. Do you remember reading, taking reading? Same as here in the micrometer screw gauge, you have 4 steps, same as vernier caliper. The micrometer screw gauge, the first step is get the linear scale measurement. Get the linear scale measurement. Get the linear scale measurement. The first step is get the linear scale measurement. Now, the linear scale measurement is the maximum linear scale value you can see. That's the linear scale measurement. Then what is the maximum linear scale measurement you can see? Then up to now 5 you can see, 10, 11, 12, 13 is the maximum. 13 millimeter is the maximum linear scale measurement you can see. Then linear scale measurement is 13. Understand, the linear scale measurement is 13. Maximum linear scale measurement you can see. That is the linear scale measurement. The second step is, understand, focus. The second step is coincide parts with the, same as vernier caliper, coincide parts with the linear scale middle line. Circular scale, coincide parts with linear scale middle line, with linear scale mid axis, I will mix axis, linear scale mid axis. What is the meaning of linear scale mid axis? This horizontal line, is the linear scale middle axis. Now with linear scale middle axis, what is the coincide one value? In the circular scale, 15. Understand, 15 is the coincide value. 15 is the coincide value. 15 is the coincide value. Then third is same as vernier caliper reading. Third step, this coincide parts multiply by the least count. Coincide parts multiply by the least count. Simple. Okay, the coincide part is 15. Then 15, what is the least count? In our syllabus, the common instrument, the least count is 0.01 millimeter. Then always multiply 0.01 millimeter. If then in the question not given specific least count, you can use this one. Okay, no issue. Then the value is 0.15. 0.15 millimeter is the value. Then final measurement, the final measurement you can get. Now you can imagine what is the method. Final measurement, the main linear scale value 13, the linear scale value 13 millimeter. The third one answer, third step answer 0.15. The circular scale value actually 0.15 millimeter. Then the adding these two value, we can get the final measurement 13.15. 13.15 millimeter. 13.15 millimeter. Then we can say this instrument, my pen thickness is 13.15 millimeter. And are you got? Understood? Please send me understood quickly. Others, if any doubt about the lesson, you can ask during the lesson. Okay, no any issue. If any point you can't understand, you can ask. Okay, okay, okay. Yes. Others, okay, okay. Before go to the exercise today, full practice this all exercise. Okay, then go to the page number 9. Tute. Go to the page number 9 in the tute. The object to be read between anvil and spindle and sorry. Okay. The place the object to be read between anvil and spindle and get the reading on linear scale. Okay, get the reading of the linear scale. That is the get the reading of the linear scale. That's the first step. All steps I have given in the tune. Then read the number of division on circular scale parallel with the linear scale. Then read the number of division on the circular scale that parallel I have given. It should be coincide. It should be coincide. Okay, correct that. Okay, there's a mistake. Circular scale that coincide with the linear scale middle axis. Please correct that. That should be. Then read the number of division on the circular scale that coincide with the linear scale middle axis. Okay, correct that. Okay, I corrected. I'll read again. Then the second point, then the read the number of division on the circular scale that coincide with the linear scale middle axis. Okay, this is second step. Middle axis, mid axis. Multiply by its multiply with by this value by the least count of the instrument and add its value to the linear scale value. Okay, understood? Simple. Okay, then I have given some space here in the page number 9. Page number 9, you have some space. Draw this and write down this step. Sorry, draw this and write down this step and this calculation. Then we can go to the exercise. Okay. Okay, completed. If you don't have tute, you can use additional paper and you can write. Okay, you can take an extra paper in your book also. You can uh, write the topic, taking measurement by using micrometers to gauge. Then you can draw and you can write down steps. And somehow, if you have or if you don't have tute, you can't. You have to work. Okay, don't think the tute will come. Until tute is coming, you have to work. Okay, completed. LS mean linear scale. LS mean linear scale. Completed. Yes. Yeah, done. Okay. Now I will give you, before we go to the tute exercise, I will give you one more question. Then if you send me correct answer, we can go to the tute. Okay. Oh, can we change the page? Can we erase that? Okay. Okay. Now draw this. Don't need draw. Don't need draw. You can see this. This is the linear scale. And this is the linear scale middle line. This is the okay. Then this is the 0, 1, 2, 3, 4, 5, like this. That is a linear scale. Okay. Then this is the circular scale. This is the circular scale. This is the circular scale. Then okay. Now okay. Can you read this value? If you can, perfect. I think these lines you can clearly see, no? You can clearly see these lines, no? Yeah, answers are sending. Very good. Very good, very good, very good. Others, very good. Yeah, four answers all are correct. No, only you have to think again. Others are correct. Very good. Okay, we'll see. What is the first step? You need to get the linear scale measurement. The linear scale, what? Up to now 10. Linear scale final value you have to get. You can see. It is 10, 11, 12. You can see another value, no? 12, the final value. It's like this 10, 10.5, 11, 11.5, 12, 12.5 is the final value. 12.5 millimeter is the final value. The below lines also you have to think. That is 0.5 values. 0.5 values. 12.5 millimeter. 12.5 millimeter. 12.5 millimeter is the linear scale value. Now you don't need to write steps. You can follow the order. Then what is the circular the coincide parts with the linear scale middle axis? 20, 21, 23. Always remember this circular scale values go into upward. Values increasing into upward. 15, 20, 25. Given diagram, always they're going upward. That's keep in mind. Okay, always that they're going in upward. Then 20, the next value is 21, 23. Sorry, 20, 20, 21, 22, 23. The 23 is the coincide part. 23 coincide part multiplied by the least count 0.01 millimeter. The value is 0.23 millimeter. 0.23 millimeter. 0.23 millimeter. Then 12.5 plus 12.5 plus 0.23 millimeter. Then you can get the value 3, 7, 12.73 millimeter is the reading. Are you got? The linear scale value only you are wrong. Others correct. Other steps correct. Yes. Okay. Everything understood? Then can we go to the tute? Okay. Before tute, I will give you another one. Okay. Okay. Do we need draw this? Okay. If you want, you can draw this. I will give you 1 minute. If you want, you can draw this and note down the answer. Okay, I will give you another final example before go to the tute. Okay, tute also you have 4 example, 4 exercise. Okay, I will change the same one. Okay, what do you think? What do you think? What is the value? Quickly send me the value. Yeah, the answer is coming. Very good. Very good. All are correct. Very good. Now, simple. You got the idea. No? Very good. All are correct. Very, very good. Okay. The what you need first? Uh, First, you need to get the linear scale measurement. The linear scale measurement now 7.5 millimeter. Then you need to get the coincide part with the linear scale midline. The linear scale with linear scale midline, the coincide parts are always we need to write, always we need to go into upward, then 45, 46, 47, 48. 48, no? Then 48 multiplied by 0.01, it is 0.48 millimeter. 48 millimeter. Then you need to add these two values. The answer is 7.98 millimeter. 7.98. All are very good. Okay, very good. Other thing, the Saad, you have to mention when you uh, send answers, the unit is compulsory. Yeah, that only mistake. Other all are correct. The unit is compulsory. Otherwise, you wrong. The 7.98 only if you send, if you write anywhere, we don't know it is centimeter, millimeter, kilometer. Good. Okay, now come to the okay, this one. First one. First one. Use your if you don't have only tune, if you only if you don't have tune, use this figure and get the value. Okay, no issue. Yeah, send answers. This one value. What is the linear scale value? 15, no? 15, yes. Oh, how it become 4.5? Yeah, others send. Now time enough. Then okay, all are correct. Third, you have to again again go to. Okay, the what is the linear scale value? The linear scale value is 15. No, the linear scale value is 15. The 15 is the linear scale value. 15 millimeter is the linear scale value. Then you take blue color. Yeah, both same. The 15 millimeter is the linear scale value. Oh, sorry. Then what is the coincide part? Coincide part 30. Simple. Then 30. 30 means multiply by 0.01. Therefore, 0.30 millimeter. What is the value? 15.3 millimeter is the answer. 15.3 millimeter is the answer. Okay. Sad, what happened? Now are you got? Others all are correct. Yes. Okay. Come to next one. Can I erase? For go next one, I have to erase. Okay, try to get all the correct to all need to answer. Only 3. Now correct, sir. Very good. Okay, what you need to do? First of all, you need to get the linear scale. Okay, first of all, you need to get the, oh, what happened? Linear scale value. The linear scale value is 21, 21.5, 22, no? 22 is the linear scale value, 22 millimeter is the linear scale value. Plus the coincide parts 30, 31, 32, 33. 33 is the coincide part. 33. 33 multiplied by 0.01 millimeter. 33. Then 22 millimeter plus 0.33 millimeter. The final value is 22.33 millimeter is the reading. 22.33 millimeter is the reading. 22.33 millimeter is the reading. They all are correct. Therefore, now more into third one. Third one. See carefully. Third one. Yeah, you have seen the answers. Yes. Yeah, in this one, the 6, you can very small piece of 6 part you can see, no? Then linear scale value is 6 millimeter. The linear scale value is 6 millimeter. The linear scale value is 6 millimeter. 6 millimeter plus the coincide part is 40, 41, 42. Always going in upward. Okay. Always going in upward. 42. Then 42 multiplied by 0.01, 0.42 millimeter. The value is 6.42 millimeter. 6.42 millimeter. 6.42 millimeter. 6.42 millimeter. Okay, final one. Yeah, just looking, you send me answers. No, good. Yes, good. Others? Yeah, send answers. Send. Very good, sir. Yes, the linear scale, the final value we can see is 7.5. 7.5 millimeter plus the coincide part is 20, 21, 22, 23, 24. 24 multiplied by 0.01, 0.24 millimeter. 0.24 millimeter. Then the 0.24. Now these cases you need to careful. 7.5 millimeter plus 0.24 millimeter. You can use calculator, no issue. Then 4, 7, 7.74 millimeter. The answer should be 7.74 millimeter. 7.74 millimeters. Okay. Are you got today lesson? Today we discussed the second part of the micrometer screw gauge. Then very small 1 hour lesson we have next day. Only 1 hour need. For next day we need only 1 hour for the errors of micrometer screw gauge. The zero error, the errors of micrometer screw gauge we discussed the first 1 hour of the next week. Then we start the our next instrument in the next day. Next instrument also we need to start in the next week class. So, okay. Okay. Now, if you have any doubt about our class or whatever clarification, now you can ask. Now that's today lesson. Now you can ask. Okay. Any doubt of the lesson or of any other issue or syllabus or whatever subject or stream or whatever, you can ask now. No issue? No doubt. Okay, then if you don't have doubt or problem, we can finish class for today. The thing is, okay, don't misunderstand. This is for 2020 student. This is only your tute pack. You don't have another tute pack until this one is complete. Okay, until forces and rotational motion complete, you have another tute pack. It will come to your previous you have filled. No, then it will come to your home. Okay, therefore I have upload you all previous uh, taken tute. I have uploaded into the system. Then automatically they will come when these lessons are complete. Therefore again the tute again don't fill this Google form. Okay, again don't fill. You have only these 3 tutes. Okay, then after other three tute I will send after this 3 lesson is complete. Okay, then what other problems? And don't miss any class. Don't miss any class because we are discussing now very practical things. Therefore, don't miss any class. Uh, always try to come to live class. If there are any unavoidable reason, you can go through recording. Somehow you have to complete. Okay, go through recording or live class. So somehow you have to complete your works. Each work, each week work. Don't take for next week. It will very damaged for your future. Therefore, this is only chance you have to you can improve your life, improve your decide your life. Therefore, take it very productive way and complete week by week. Complete each work with perfect way. Okay. Do you have any doubt? No. Okay. Then good night. Uh, the final thing, practice this. Okay, the now uh, Yeah, one more point. Now you have completed how to get the reading of the vernier caliper. Now today we discussed. Uh, Today actually you can do this, but after 1 or 2 weeks you have to again try how to get the. Then we have exercise. No? Then you can again go through exercise. Can you get these readings? Can you get identify these errors? Okay, after next week we discuss the zero error of the micrometer. Then we listen zero error of the vernier caliper. That's why now little bit coming bulk. No, the each instrument same topics we discuss. Therefore, you have to careful. Okay, you have to careful and work in perfect way. Okay. Good night.